Okay, so solubility, no? So basically, solubility is it involves a solute and a solvent, diba? Solute, for example, sugar, salt. We call that our compound. Solvent naman is our liquid, let's say water. Sabi dito, the greater interaction between the solute and the solvent, then the better the solubility is of the solute to the solvent. So yun, essentially, greater interaction means better solubility. This is the energy that is needed to break up the interactions between the molecule or ions of the solute. So, it's just another way of saying na, kunyari, we have salt. We want to basically dissolve it. Yung molecules or ions of the solute, it has to be broken down. So, magkakaroon ng new interactions between the solute and the solvent. So, something that you have to know that's very important is that like dissolves like. What does that mean? So, compounds dissolve in solvents having similar kinds of intermolecular forces. So, there are two scenarios basically that are based on that idea. So, kapag sinabi natin polar compounds or polar solutes, they dissolve in polar solvents. So, anong example nito? If you mix water and alcohol. So, clearly, water is polar, di ba? Kasi there is a significant difference between the electronegativity of oxygen and hydrogen. Pati yung... Actually, ganun din sa alcohol, di ba? Alcohol group, OH. So, both of them are capable of hydrogen bonding. By the way, H bonding is gonna be very popular in the context of solubility. So, ayun, they dissolve in polar solvents. Big sabihin, parang in a way, hydrogen bonding is involved. Kung hindi kaya mag-hydrogen bonding, ibig sabihin, insoluble. Or you cannot dissolve this specific compound or solute in a solvent. So mamaya may summary yan. Actually, it's this one. What I'm saying right now is basically gonna be summarized here. More on that later. So, other one naman, common sense. Kung polar to polar, edi non-polar to non-polar. Meron pa, weakly polar. Halos pareho siya sa non-polar but there still is quite a kind of a distinction. So, weakly polar to weakly polar. Ganun lang naman. Examples of non-polar solvents, we have carbon tetrachloride and hexane. Sa weakly naman, diethyl ether. Yun yung example sa presentation. Okay, solubility of ionic compounds naman. Basically, we're testing the solubility of ionic and organic. So for ionic, they are soluble in water, but they are not soluble in organic solvents. Isang halimbawa ng organic solvent is ito, CCl4. Tama, no? Yeah. Solubility in organic solvents, an example is CCl4 because it's non-polar. So, if you want to dissolve an ionic compound, the strong ion-ion interactions must be replaced by many weaker ion-dipole interactions. Okay? For the solubility naman of organic molecules, essentially, you just have to look at the polarity. You want to see if yung organic compound natin, it is capable of hydrogen bonding. More specifically, kung kaya niya mag-hydrogen bond with the solvent for every 5 carbon atoms. This might be overwhelming at first to think about yung specific condition nito. But later on, it could help Sorry. It could help narrow down kapag na-discuss na natin to. Okay? So, let's try butane. Butane, based on the structure, puro ano lang, di ba? Hydrocarbons. So, in that case, there is no hydrogen bonding na nangyayari. So, naturally, it is soluble kapag organic solvent. Pero kasi, when you dissolve it in water naman, since it's not capable of hydrogen bonding, it's insoluble. Sabi diba, this is the condition. So it is only water soluble if this condition is met. Basically, kaya mag-hydrogen bonding. Butane cannot. Unlike yung dito, acetone, as you can see, we have an O and we have a C. Essentially, although parang hindi siya direct, diba? Hydrogen bonding is supposed to be OH, FH, kaya SH, diba? Tama ba? ONS. FON. But essentially here we have a better bet compared to butane. This can do hydrogen bonding. So, hindi lang siya soluble with organic solvents, pati rin sa water. How about water solubility of the organic molecules? It's just a continuation of what I'm talking about. So, the size of an organic molecule with a polar functional group determines its water solubility. So, ano yung trend specifically? So, low molecular weight means it's water soluble. So, it's basically an extension of this condition. So, yes, it is water soluble, yung organic compound natin, kapag it is capable of hydrogen bonding. But there's a limitation. Diba I said kanina, 5 carbon atoms. Dapat less than 5 or equal to 5 lang. Kapag humigit ng 5 carbon atoms, and sabihin natin we only have just an alcohol group, hindi, parang the capacity is ma-overextend in a way. Para siyang ratio. So if we have one alcohol group, this can only cater to 5 carbon atoms. I hope that makes more sense. Kapag dalawa, edi 10 carbon atoms. Parang ganun. But kasi, in the case of, I'll mention it na, in the case of cholesterol, we only have one OH group. And we have 27 carbon atoms. That's certainly bigger than 5, diba? So, this is an example. So, basically, cholesterol is capable of hydrogen bonding, but because it has too many carbon atoms for having just one OH group, hindi siya water soluble. So, yun lang. Dito naman sa ethanol, clearly, may OH tayo. We only have 2 carbons. It's within the 5 carbon atom limit. So, it is water soluble. Ganun lang naman. So, yes, this is the summary. Kapag ionic compounds, soluble in water, insoluble kapag organic solvent. That's standard. Pag naman covalent, we have 3 conditions. So, one example to that is yung butane. Butane natin, walang heteroatom. So, there's no way that hydrogen bonding could be done to water. So, insoluble. Kapag naman merong O atom, or let's say N atom or F atom, pwede mag-hydrogen bond basically. And it is less than or equal to 5 carbons, yung compound natin, then it's soluble. Kapag naman sumobra, tulad ng cholesterol, it is insoluble. Because again, it's too large. The number of carbon atoms are too much. So, but yes, kapag covalent, it's standard na kapag you mix the covalent compound in organic solvent, it's the same thing that would happen. It's soluble in all cases. Okay? To, surnil lang to. Hydrophilic, hydrophobic. It's basically about soap. So, paano niya natatanggal yung oil? Basically. Yung hydrophilic portion is composed of the polar head, hydrophobic. Actually, to be honest, I still have to brush up on this part. Or maybe just about soap. Let me see if I can discuss cell membrane. Ito, phospholipid bilayer. Sa ano to biology. So, polar heads oriented towards the aqueous exterior. Non-polar tails forming a hydrophobic interior. Do you remember this? So, ito yung heads. They are hydrophilic, and inside we have the hydrophobic tails, which are non-polar. Polar, ang exterior, yung heads natin, because I think it makes sense kasi nasa labas yung water, di ba? The head has to be polar because water is polar. I hope that logic is right. Just to be sure, you can research on that too. That's it.